back to our channel Physics Tutorial. Today we are going to discuss plus 2 physics practical. Now we can see how to do the convex lens experiment. Can we move to the experiment?
Here the aim of the experiment is to determine the focal length of the given convex lens. So here we will find the focal length by using distant object method, then UV method also. Okay. Also we can calculate the value of f by using UV graph and 1 by u 1 by v graph. Okay. Now the apparatus required are convex lens, screen, illustrated wire gauze, or we can use a cantle instead of wire gauze. Okay, then stand, meter scale, etc. Now we have to check the principle used. So in principle we have to write down the three equations. The first one is, in the case of UV method we can find the focal length by using the equation f is equal to uv by u plus v. Here u is the distance between the object and the lens, or the object distance, and v is the distance between image and lens, or image distance. And also we can calculate the focal length by using UV graph, and the equation is f is equal to OA plus OB by 4. Okay, here OA and OB are the coordinates at the point where u is equal to v, so that we can find from the graph. And in the case of 1 by u 1 by v graph, the focal length is calculated by using f is equal to 2 by OA plus OB. Here OA and OB are the intercepts on the x-axis and y-axis. So these three equations with symbols specification you have to write down. Okay. Now we can discuss the procedure. So first of all we can find the focal length by using distant object method. So here what we have to do is we will keep the convex lens in a stand, and we have to focus a distant object. And after that we will place a screen just behind the lens, and now we will adjust the position of the screen in order to get a clear image on the screen. Okay, here we can see that the screen is just kept close to get the clear image. That means we are adjusting the position of the screen for getting the clear image of the distant object. So when we are getting a clear image, we can stop the screen there, and then we have to find the distance between the screen and the convex lens. So that will be the focal length. So whenever we are taking the measurements, make sure that we are taking the measurement from the center of the screen to the center of the stand. That means the lens stand. Okay. Now we can repeat the same experiment and find the mean of focal length. So that will be the focal length of the convex lens by using distant object method. Here the ray diagrams are very important, so that we have to study, and then we can just tabulate. That means here only the focal length we have to mention, that is in centimeters, then find the mean of focal length. So that will be the value of focal length. Okay. Now we can find the focal length by using UV method. So here the experimental setup is as shown here, and here we can see the convex lens is mounted on a stand and is placed in front of a cantle. Okay, and on the other side we have to keep the screen. Right, now here we have to take minimum 6 or 7 set of reading. It is better to take 7 set of reading, because then only we will get the shape of the graph. Right, for that now we have already found that the focal length is, suppose we are getting it as 10 centimeter. Right, because the focal length we can find by using the distant object method. That is how we know the focal length now, isn't it? Now we can use that focal length, because this is an easy method to find the u and v. Right, so we know that at 2f the position of object and image should be at 2f itself. That means u and v will be at 2f only. Suppose we are taking u as 2 into 10, that is 2f, right? So that will be 20 centimeter. So that 20 centimeter distance we have to take from the lens to the object, that means cantle. Then we can keep the screen also at 20 centimeter from the same convex lens. Now we can see the image on the screen, and the image should be inverted and should be having the same size as that of the object. Okay, and now we have to repeat the experiment for the different values of u, that is object distance. Now we can write the values of u and v. Okay, here we are getting u and v as 20 centimeters. Right, now we can write that, and now we have to repeat the experiment for different values of u. So for that, it is better to take that 3 values just before 20 and the next 3 values after 20, so that shape of the graph will be perfect. So it is better to take the values of u as 14, 16, 18, 20, 22, 24 and 26. So that 3 distances, that means we can keep the position of the object, that is the cantle, at 14. That means the distance between the cantle and the lens should be 14. Then we can move the screen in order to get the corresponding image, so that we can write down the values of v for corresponding u. Okay, and whenever we are taking the reading, make sure that the image is very clear and that end should be sharp, then only we can take the reading. Okay, now we can calculate the value of f by using the equation f is equal to uv by u plus v. So we can substitute the values for each reading and then find the mean value of focal length, that is f is equal to uv by u plus v. So that will be the focal length by using uv method. Here also the ray diagram is important and that you have to study, and here also we have to find the 1 by u 1 by v, because that graph we have to draw, 1 by u 1 by v graph we have to draw. So that values you can calculate and write in these 2 columns. Now we have to calculate the value of focal length from uv graph. So first of all we have to draw the graph. For that, the value of u is taken along x-axis and v along y-axis. The values are taken in centimeters, and the scale we have to mention, that is x-axis 10 division is equal to how much centimeter we are taking, and along y-axis also 10 division is equal to dash centimeter. So that values we have to mention there, and then we will get the graph as shown here. And from this we will make that 45 degree. So that should be exactly at 45 degree, and OA and OB we will measure. Then we can find the focal length by using the equation f is equal to OA plus OB by 4. That means at the exact center we have to draw this OC. Okay, then that into 10 raised to minus 2 meters will be the focal length. Now we can calculate the focal length by using 1 by u 1 by v graph. Here we have to take 1 by u along x-axis and 1 by v along y-axis, and the unit is centimeter inverse, and we have to mention the scale, that is x-axis and y-axis, which all quantities we are taking, so that we have to write down. Then we will get the shape of the graph like this. Okay, now we can join this OA and OB. So we have to find the values of OA and OB. Then focal length can be calculated by using the equation 2 by OA plus OB. So that into 10 raised to minus 2 meters. So that will be the focal length by using 1 by u 1 by v graph. This experiment is actually very easy and important. So I think it is clear to you, and now we have to write down the results. So whenever we are writing the results, we have to write down the focal length of the convex lens by distant object method, then by using UV method, and from UV graph then 1 by u 1 by v graph with units we have to mention. For exam, it will not be asked the 4 methods. Okay, any 2 will be asked. So according to that you have to do the experiment. If 2 are asked means no need to draw all the graphs. So which one is asked, that you can write as result also. Okay.
Now we are going to conclude the video. If you like my video, please like, share and subscribe. Thanks for watching.